Hello and welcome to the August edition of the European Young Chemist Network podcast. Here we discuss the latest research concerning chemistry-related topics of high interest to the general public. My name is Aurora Walsh. Up next, our EYCN delegate from Romania, Robert Andrei Tinku, interviews Dr. Mark Kelada from Ireland on the important topic of microplastics. Dr. Kelada has a Bachelor of Science degree in Pharmaceutical and Biomedical Chemistry and a PhD in Medicinal Chemistry from National University of Ireland, Maynooth. Currently, he is a laboratory analyst in Ballina Beverages and is also the Young Chemist Convener of the Institute of Chemistry of Ireland. Today, we will discuss with Dr. Kelada what the correct definition of microplastics is, how they're formed, and advantages or disadvantages associated with them.
Hello, Mark. It's good to have you here today.
Thank you very much, Robert.
Can you tell us what are microplastics?
Yeah, for sure. Microplastics is such a huge topic at the moment, and a lot of people are concerned about it. A lot of people are worried about it. But unfortunately, the research isn't spreading as much as it should in order to answer people's questions. So I think it's a great idea that we're doing this podcast in order to kind of inform people a little bit more about what are microplastics and the dangers, if any of them, and what they are and how they're used, etc. So to start off, there are multiple definitions for microplastics in the world from researchers all over the world. And if you look online, you'll see research from America, from Germany, from Ireland, from you name it, right? So, however, the most current and accepted definition at the moment is from Professor Fries, who published an excellent review in 2019. In this review, he defines microplastics as any synthetic solid particle or polymeric matrix with regular or irregular shape and with size ranging from 1 micrometer to 5 millimeters of either primary or secondary manufacturing origin, which are insoluble in water. And I personally think this definition is brilliant because it completely encapsulates a lot of previous definitions, and it's also clear. It's unambiguous, right? Because some researchers, unfortunately, because it's such a new topic, they weren't really sure about size and they weren't really sure about material and so on. And so they sometimes say, oh, there's microplastics here, but it may not fit into that definition. So I really personally love that definition from Professor Fries. How they form? From looking at some research and from just reading a few different articles and different reviews, there seems to be 4 main ways in which microplastics are formed. So that can be direct manufacture, where microscopic or small plastics are purposely made, like, cosmetics, exfoliates, things like that. The second way is fragmentation of larger pieces of plastic. So these can kind of degrade after prolonged exposure to the elements. Number 3 then are microbes from ropes and textiles, things like that. And number 4 is tire and road paint particles. And this can be done during transport via runoffs from roads and things like that. So they're the main 4 ways that microplastics are formed. But as you can see over different reviews, that researchers have been really looking at this over the past 10 years from lots of different angles. So it's quite interesting.
Okay. So you said there are some uses for these microplastics. Can you tell us some of them?
Yeah, like plastic in general, microplastics. Plastics in general can be used for, obviously, drinks, for food products, for medicine. We use plastics every single day of our lives. And a lot of people are concerned about how we use plastics and how we deal with it. But it's actually how we throw away our plastic is the important part, right? So, as I said, plastic is versatile, low density, low thermal electric conductivity. It's resistant to corrosion. It can serve as a water and oxygen barrier. It's quite cheap and it's useful in many applications. And so plastic in itself is very good, but how we recycle plastic and how we reduce our plastic usage and how we reduce our plastic waste, that's critical. So it's not the actual material, it's how we ourselves use it and how we get rid of it. And so from that then, microplastics have many uses. Example, they're present in numerous personal care and cosmetic products. If you look at any soaps, lotions, facial and body scrubs, toothpaste, etc., you'll see there's microplastics used in their manufacture and in them. And when used, the microplastics in cosmetics are rinsed directly down household drains. And then they end up in wastewater treatment plants. the cosmetic product formulators have already begun to gradually phase out the use of any unnecessary microplastics, but they are used in there. So there are a few different applications for microplastics, huge in the cosmetic industry.
Okay, so from what you are saying, I can understand that microplastics are a wonderful material. For sure, they have some disadvantages, right?
Yeah, I mean, disadvantages, everything has advantages and disadvantages, right? So, for example, we don't want to ingest microplastics in our diet because then that will reduce the amount of energy available for growth and reproductive success. And just thinking about it, even if you're not a scientist, thinking about eating plastic or microplastic isn't the best dietary.
Yeah, it's not.
Yeah, right. So maybe not. So that's the kind of disadvantage of having microplastics sometimes in almost everything. Depending on where they were used in, they can also be a source of contamination, right? Because if they're in plasticizers or additives, etc., during manufacture, then that could be carried along. So there are kind of disadvantages that we worry about when we use microplastics or plastics in general, but lots and lots of research is ongoing to try and, first of all, detect if there's microplastics in there, and second of all, to try and reduce it if there is.
Okay, so we have to find a way to just remove it from the environment if they end up there, right?
Yep,
So
exactly.
what are the techniques, the processes that are used now for removing those microplastics from, let's say, wastewater or
Yeah,
other?
so for example, in wastewater treatment plants, there's 3 stages of purification or filtration, if you like. So that's primary, secondary, and tertiary, right? So at the moment, microplastic particles, because they're so small and they're so like finite, limited sizes, they are removed during the primary treatment zones. They use different techniques like solid skimming and sludge settling processes, and that's how they remove microplastics from our water that we drink. Because again, as I said, nobody wants to drink water with microplastics, but they're very, very careful to try and remove that from the very beginning in the primary stage.
Okay, so that's the only treatment, the primary treatment of the wastewater?
So far, yeah.
Oh, okay, so it's not that difficult to remove it from
because if you think about it, the secondary and tertiary are much bigger things are removed. So in order to remove the small size microplastics, it will be from the primary treatment zones.
So if this process fails, what will happen to the environment? What are the effects of these microplastics on the environment? And maybe
it's a very good question. That's $1 million question, and that's a PhD thesis question. You know, there's lots of research going on at the moment, but unfortunately, no major researchers have found the main toxicity of microplastics in, say, food or drink or chemicals or anything that we use. There's no known toxicity related to microplastics. So as we all know, just to give our listeners some background to how we measure toxicity, there is no observed adverse effect level. So that's the NOAEL, NOAEL. That's if it doesn't have any toxic level that we can observe. Okay. Then we have something called the lowest observed adverse effect level, which is LOAEL. And that's if we observe something, but it's very, very low, and that's the lowest amount. And some governments, some countries, some companies, some institutions have a set amount of LOAEL, the lowest amount that can be observed of toxicity from microplastics in their beverages, their food, their products, and it should be below that, right? Then there's also the lethal dose, which is 50%, so that's the LD50, or the lethal concentration 50%, which is the LC50. And so that's how we measure toxicity, but there isn't much research going on at the moment about toxicity of microplastics. So again, it's not ideal to have it in your drinks or in your food or in your products or in your face masks, etc. But how toxic is it and how much toxicity is there, we still don't know. honestly, like we like there's so many things to talk about in terms of microplastics, and there's so much reviews out there and so much definitions. But unfortunately, the media sometimes paints the wrong picture about microplastics and the dangers of plastics usage and so on. But if we're careful, if we use things correctly, then it won't be dangerous, right? So if I take a plastic bottle, I drink the contents, and then I recycle it or I put it into the correct bin, then it can be reused or it can be recycled. It can be used for a different purpose, and that's okay, right? But if I take a plastic bottle and I use it the wrong way and I don't recycle it the right way, then that's the problem. Or for example, if I keep reusing the same plastic bottle, then that can degrade the plastic and therefore produce microplastics. And therefore you could be ingesting and drinking microplastics. Is it dangerous? We don't know. But let's be on the safe side and recycle things correctly so that we avoid any future problems.
Yeah, that would be the best thing to do, in my opinion, also. And just don't listen that much to the social media, because sometimes they exaggerate things.
Absolutely, yeah.
Yeah. Okay, so thank you very much, Mark, for speaking today.
No problem at all. I hope you all enjoy. And as I said, a lot of this is based on personal opinion or based on research reviews or based on what I've read. But there's obviously so much research out there. So if I've missed anything or if I said anything incorrectly, I apologize. And I'm happy to have a discussion with anyone who would like to talk about this topic. But again, I apologize if I've said anything incorrectly. That's just based on what I've read so far.
Hey, it's Aurora again. I hope you enjoyed our interview with Dr. Mark Kelada, and if you have any further questions about microplastics or anything else discussed in the interview, please feel free to contact us by email to podcast@uicn.eu. And now we come to the news section, where we would like to present to you some fantastic research articles from the last month. First up, are we going to live in transparent wood houses? In an article in Nature Communications, a team of American and Swiss researchers have presented a new process to make conventional wood transparent for sunlight while keeping its prominent wood pattern. The process is based on a spatially selective delignification of the wood via sodium chloride and acetic acid. The removed lignin is then replaced by a refractive index matched epoxy. This new aesthetic transparent wood could be used as a sustainable building material due to its low production cost, low thermal conductivity, UV blocking ability, and high mechanical robustness. Computing with molecules. Moore's law states that the number of transistors on a computer chip doubles roughly every 2 years. This has been true since the 1960s. However, this exponential growth will come to an end with the current silicon-based technology due to various technological and physical limitations. In an article in Advanced Materials Interfaces, Indian and Belgian researchers have shown an alternative to the classic transistors by employing molecular motors as electronic counter substitutes. They adsorbed 2,3-dichloro-5,6-dicyano-1,4-benzoquinone, or DDQ, onto a gold surface and observed a conformational change based on the applied bias voltage. This allows conversion of the analog input into digital information while decreasing the size of the electronic counter by 2 orders of magnitude. And finally, connections between family income and children's brain development. A recent study in Nature Communications shows the impact socioeconomic status can have on the brain. Previous studies have already shown a connection between the parent's income and a child's memory and language abilities. While the reasons behind this correlation have been rather speculative, Canadian researchers have been able, for the first time, to measure a physical difference between children from poorer households and their wealthier peers. They found that anterior hippocampal volumes positively correlate with family income up to an annual income of about $75,000. This difference also correctly predicts the strength of gaps in memory and language, as the anterior hippocampus is very sensitive to stress. We hope you enjoyed our podcast and stay tuned for our next edition. My name is Aurora Walsh, and this was the podcast of the European Young Chemist Network.